Hi everyone. Today we're going to be talking about two common forms of arguments. They are called Modus Ponens and Modus Tollens. Now these are two of the most common forms of arguments in mathematics, so it's reasonable to ask why they work. And we're going to take a step back and look at formal logic to see why it is that these are actually valid methods of arguments. Before we do that, let's look at truth a little bit. We say that 0 is false and 1 is true. And based off of those, we can make truth tables for logical operators. Now, there are a few common logical operators, and we're going to need several of them. One of them is or, there's and, there's not, and there's the implication. So let's draw the truth tables of these just in case you haven't seen them before, but most likely you should have seen them. We have P and Q, P or Q, P and Q. Let's look at these for now. There are four possibilities: 0, 0, 0, 1, 1, 0, and 1, 1. For P or Q, the truth table gives us 0, 1, 1, 1. And P and Q, the truth table gives us 0, 0, 0, 1. Next, let's look at the not operator. We have P and not P. There's only two possibilities in this case, 0 and 1. And we just flip them to get 1 and 0. And finally, we have the implication operator. Now, you might be wondering what exactly that means. And so that you know, P implies Q is logically equivalent to not P or Q. So that's how I would derive the truth table of the implication symbol. We have P and Q, and we have P implies Q, which is the same as not P or Q. And just in case, we're going to write down not P as well. 0, 0, 0, 1, 1, 0, and 1, 1. For not P, we just flip all the P's, so we get 1, 1, 0, 0. And we want to look at not P or Q. So in this case, we have a 1, a 0, and a 1. So P implies Q is always true unless we have a true thing implying a false thing, like here. Otherwise, we have a 1, and a 1. Okay, so now that we have the preliminaries over with, let's actually look at Modus Ponens and Modus Tollens. What are these arguments? Modus Ponens is the following kind of argument. We have P implies Q and Q. So these two over here are called the premises, and this one is called the conclusion. And Modus Tollens says not Q, P implies Q, and not P. Once again, the first two are premises and the last one is a conclusion. And this should intuitively make sense. For example, if P equals to I am holding an orange, and Q is equal to I am holding a fruit, then these two arguments actually make sense, because in this case we're saying I'm holding an orange, then we're saying if I'm holding an orange then I'm holding a fruit, therefore I am holding a fruit. And in this case we're saying not holding a fruit, and then we're saying again if I'm holding an orange then I'm holding a fruit, and finally we're concluding that I'm not holding an orange. And this should make sense, but it being intuitively clear is only the beginning. We need to also justify it using formal logic. So let's do that. What we're going to do is draw truth tables of these arguments. And you'll see what exactly it is that makes these arguments valid. We have P implies Q, and Q. So let's draw the truth table of that. The assignments are 0, 0, 0, 1, 1, 0, and 1, 1. P implies Q is, the truth table of that is 1, 1, 0, 1. And I'll show you just in a moment what's going on here. Let's just draw the table for Modus Tollens as well. We have not Q, P implies Q, and not P, but for the assignments we need P and Q as well. So we have 0, 0, 0, 1, 1, 0, and 1, 1. To get the not P's, we just flip all the P's, so we get 1, 1, 0, 0. And to get the not Q, we just flip all the Q's to get 1, 0, 1, 0. And once again, the P implies Q's truth table is 1, 1, 0, 1. Okay? Now here's the rule that we have to follow. The premises being true, so 1, leads to the conclusion being true, 1. So let's see when that happens. In this case, the premises are true only in the last line, 1 and 1, and they do lead to the conclusion being true as well. And in this case, the premises are true, both true only in the first line, and indeed they do lead to the conclusion being true as well. And this should intuitively be clear that we want the truth of the premises leading to the truth of the conclusion. So that's why these methods of argument are valid. So let's do a quick recap. we started with 0 and 1. We stated that we have to draw truth tables. We looked at logical operators and their truth tables over here, and over here. And then we looked at what Modus Ponens and Modus Tollens are in terms of their argumentative structure. And finally, we showed that Modus Ponens and Modus Tollens are valid because whenever the premises are true, the conclusions are true as well. Okay, thank you for watching, and I'll see you next time.